What's up, y'all? Welcome back. I know it's been a while, but I've been busy with some school stuff. But yeah, let's get straight into it. Today we're going to be solving Leetcode problem number 11, container with most water. And I did this a while back. It was pretty fun, pretty interesting. So yeah, and it's a medium problem. It's going to be the first medium I've solved on this channel, but it's not too bad. So
You are given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I0 and I at height I. Find two lines that together with x-axis form a container such that container contains the most water. Return the maximum amount of water a container can store. Notice that you cannot slant the container.
that explanation is a little confusing in my opinion, but I'll try to dumb this down a little bit because that helped me also. Using these, so let's say our x-axis, each of these bars is a value in an array, right? So here we have 1, and the next index we have 8, and so on, right? We want to find the greatest height with the greatest width that we can fill this container with. So here you can see like this right here, for this example, this is the greatest amount of height. It's filled in, and notice that it can't go over one of the bars, right? So instead of like, we can see here that this is obviously the greatest, but this would overflow. So you have to take the smaller of the two for it to be valid. And for this problem, a two-pointer approach would be the most intuitive and most optimal, but can't confirm that last part. Start here at 1, right? Say we start at 1 and we start at this one, right? So in a two-pointer approach, we're going to be comparing these two pointers, right? So we can see that obviously 1 definitely smaller than 7, so we're going to increment this way, right? So now we're at index 2 or index 1. Okay, one thing I forgot to mention was on each iteration, right, we want to keep track of the greatest, we want to keep track of the area of the container, right? So how much water can be stored. So for number 1, this is the highest the water can go. I'm using a touchpad, so don't mind me. But this is the highest that the water can go, right? And this is not very much. We want to keep track of the greatest, right? So even though we visually can see that this isn't going to work, we still need to keep track, right? And we're going to keep track of the greatest. So for each iteration, we're going to calculate the greatest. So this one's not going to work, right? So now we move to the next index. We'd calculate this again. We would check if this is greater than our last iteration, which it is. So we would set it to that. And the way we're doing that is, like I said, when we're looking at these bars here, I'll just call it these bars, you have to take the least of the two because it can't overflow, right? Like this, no go. And then for our width, this is just a little math, but you would take, so say we have, this is the x-axis, right? We have this x-axis. We have one position of x and the second position, right? So let's call it x1 and x2. The way you would calculate the distance between these two would be x2 minus x1. And this would give you the width of this rectangle. To get the area, right, you have x2 minus x1 to get the width, and then you would take the smaller of these two bars, and that's how you would calculate this area, this blue area you see here. Even though we see that we found our greatest value, we still need to iterate through the rest of this array, right? Because a computer's not going to know that. This whole area here is still unknown, right? So we still need to iterate through the rest of this, but we stored our greatest value, and that's what's important. We're just going to keep calculating, and we're not going to find a greater value. Once we reach to the middle, the loop will end. We're obviously going to be using a two-pointer approach, so we have our left and right pointers. We're going to set left to 0 and right to the length of height, which is our array, -1, because it's 0 indexed. And now we're gonna use a while loop. So while left is less than right, in some problems you might see people use left is equal to, but for our purposes, we can't have these two pointers overlap at all, because then there'd be no area. Let's declare our greatest. We're just gonna call it greatest, and we're gonna set it to 0. Just for the edge case that we have an empty array, we're just gonna return 0. And on each iteration, we're gonna be updating our greatest, and I'll show you how we're gonna do that. So let's cover our base cases, right? I'm just gonna make two variables for left and right. So call it num1 and num2 is equal to height at L. That's gonna be our num1 and height at R, num2. So if num1 is greater than num2, so let's say we're looking at this bar. If this is greater than this one, we're obviously gonna increment our right pointer. So we can do that with this notation, r minus equals 1, and obviously the opposite, and the only other option is to increment our left pointer, right? So there's one more thing that might go over some people's heads, but let's say these two bars are equal. If these two bars are equal, then what do? We have to increment 1, but it doesn't necessarily matter which one you increment. It could be right or left. So I'm just gonna include that in our first if conditional. We've got our base cases, but now we have to do our calculations, right? And we have to do that before we increment these pointers, because it'll skew our calculations. Remember we said we need to get our length and our width. So the way we get our length, by getting the smallest of these two bars, the max. So max is just a nice method that will give us the greater value of two values. I'm sorry, I meant min, right? Because we're getting the minimum, because we can't have the water overflowing. So we have our length, and now let's calculate our width. Remember we said we're just going to subtract the second position from the first position. So instead of using num1 and num2, we're just going to use the indexes. So r minus L will give us the width. And then our area, obviously length times width. Our final step, recalculating greatest on every iteration, right? In this situation, we're going to use max, right? Because we want to get the greatest value. Let's say we're in our first iteration. Greatest right now is equal to 0. And we want to compare that to our new area we just calculated, right? And all there is left to do is just return greatest at the end. Somehow I put a 1 here instead of an L. But let's submit that. And as you can see, this is a pretty optimal solution, not too bad. But yeah, if you guys have any questions, just leave them down in the comments below, and I'll see you next time.